back to 2024, prompts were what we kind of call like a one shot. You pass the prompt in and it runs. They weren't reasoning. They weren't sitting there and spinning their wheels and figuring out what to do. So now it's more about, we sort of think, how do we get the context to the model? But most of the energy, instead of let me write the perfect string, all the prompt is a string. I feel like when we just call it strings, it loses its luster, but it's a string. Instead of writing the perfect string, build the perfect tools. Build the set of tools that the agent can use to go and find context, rather than trying to be clever about pushing it all into the string that we're writing. Right. So like prompt engineering is, we've already in some sense moved past it. And you're right. We want to get to the point where, you are a helpful agent is practically all that we have to say, plus a bunch of tools. And you mentioned before, like getting a feel for writing Goldilocks data. Like one of the tricks we've seen is you start with an agent that is prompt engineered. You program in the prompt, right? It's really rich and complex. And maybe that's required to get your scenarios to work. Right. Anyone who's built sort of professionally built agents today, it can be a little tedious and there's still a lot in the prompt. What we do as we train a better model is what we call ablation. We'll go in and take that really complex prompt and start to take stuff out. Right. Maybe after the first round of training using this process I'm describing, this RL process, the agent doesn't have to be as prescriptive because some of what we intended is baked into the model now. Right. So we take that out and we repeat. And you can sort of ablate the prompt down from this novel of stuff to you are a helpful agent. Right. And that's sort of the ultimate goal, because that lets you write less stuff and still get a useful agent out the other end.
Well, that's this is, what's interesting is that ablation, I'm familiar in the healthcare setting. Ablation is a surgical procedure. Do you find that some of the concepts that are in other disciplines can be applied to machine learning? Like how valuable is to have cross-disciplinary backgrounds when we're thinking about agent performance?
Yeah, we're in a really weird, exciting place right now, right? Where this isn't just code that, I go and I run it. The models, I forget who said this, but they sort of said that, models are not trained, they're grown. There's this process of encoding human knowledge into these models that does require experts from a lot of disciplines, just as like to teach the model what humans know. But there's also really subtle, challenging questions around how do I measure whether a model is doing the right thing? It gets back to my philosophy roots. There's a lot of discussions about, seemingly settled questions, right? But no, we have to teach the model the right amount of nuance in answering something. We have to teach the model even, there's people working on, how can you teach a model to write prose that doesn't feel like model prose? Okay, how do you teach the model to write poetry, like good poetry, right? But also, how do you grapple with the societal implications of what we're doing? How do you grapple with, again, this like product integration to the model? The product wrapper needs to convey the amount of trust that we have, needs to help you gain trust. This is a really cross-discipline problem that we face of how do we not just build a new set of model weights, but how do we build a system that can automate a lot of human toil, right, that we can trust?
Yeah, that is there, when you have a very nuanced thing like writing great prose, like is there a ground truth that agents can be measured against? And
No. Luckily, I spend my days on easier problems. Maybe the bank either has money or it doesn't. The CRM either has a deal after I tell it to make a deal or it doesn't. But to do this well, to build these models, you do need to pull from all of those different backgrounds, and that's, I think, one of the more exciting things. If you look at the people doing really great work these days in AI, it's not people that just went and got a math degree. Plenty of those, but it's people from all sorts of disciplines that are attracted to this problem of like, how do we get a machine to work under massive uncertainty, right? And these sort of, every time you prompt the model, you get a different answer. So how do you deal with that amount of just change as you're measuring something? It feels more like bench science, sort of empirical to me, than it does sort of, classic algorithms where you can just like write it on a whiteboard and smart your way through it.
Right. Yeah, we definitely, IRL is a non-deterministic state. And just to illustrate, I was we have a TELUS Studio, we have an office in Dublin, and they took us out on the pub tour, and I was listening to the reading of the James Joyce reading. I said, no model's going to get to James Joyce. Like, that's just like a too high of a bar in terms of
we'll see.
Pros. Well, yeah, we'll see.
I think a model can mimic James Joyce to the point where neither you nor I, admittedly not a literature guy anymore, but like neither you nor I could tell the difference. I don't think it would be James Joyce.
Fair enough.